Hello students, let's discuss P block, and in that in 11th standard we have group 13 and a group 14. So let's start with the group 13 elements and its electronic configuration. So in group 13 you have a boron, aluminium, gallium, indium and thallium. Bangan, alu, gobi, thala. That is our easy key to remember this. And yes, definitely students. These elements are placed in the 13th. That means in a Roman, if you will say, then it is in a 3A group in the long form of the periodic table. Here it is, yes. So electronic configuration will be like 1s2 2s2 2p1, aluminium 1s2 2s2 2p1 6. That means neon. After that 3s2 3p1. In gallium, it is after argon, it is 4s2 4p1. And there is involvement of 3d10 here. And yes, in indium, krypton 4d10 and 5s to 5p1. And in thallium, xenon 4f14 5d10 and 6s to 6p1. The general outermost electronic configuration is ns2np1. So general, if we write noble gas and then outermost electronic configuration, then in the penultimate shell, boron contains 2 electrons, aluminium contains 8 electrons, and other contains 18 electrons, right? Penultimate shell means outermost के आगे जो shell होती है उसके अंदर, ठीक है? So MCQ answer NH2NP1 here. Abundance, boron is a rare element. Mainly it occurs in a combined state and it has 2 isotopic forms, that is B10 and B11. B11 is a major proportion. Boron, for boron generally we have to remember borax, orthoboric acid and a columenite. Na2B4O7 into 10H2O for a borax, H3BO3 for orthoboric acid and a columenite Ca2B6O11 into 5H2O. Aluminium is the most abundant metal and the third most element in the earth crust. Second is the iron. Corundum you have to remember. Bauxite you have to remember. And a cryolite you have to remember. That's it. And even feldspar you have to remember. So gallium, indium and thallium are less abundant and highly toxic. Decreasing order of abundance as you move from top to bottom, it is decreases, but the most abundant aluminium, gallium, then boron, then thallium and indium. This is the abundance order. You don't need to remember the values, but yes, order you have to remember. So in a borax, the formula you have a 10 mole of water. Corundum formula is Al2O3. Formula of cryolite is Na3LF6. Okay, so A and B are same. C 3 Na, that means Na3. F you have 3 and a 3, so total you have 6F. Let's go for the physical property as we go on top to bottom. In a group 13, size increases, so that is the general trend. But there is exception in aluminium and gallium and indium and thallium also. The reason behind that is there is presence of 3d10 electrons in a gallium, whereas it is absent in aluminium. Ionic radius increases from top to bottom. Ionization enthalpy value decreases with increase in atomic radius. That is the common trend. Since the outer electrons become more loosely held down the group. Yes. So जैसे जैसे साइज बढ़ता जाएगा इतना ही इजी होता जाएगा कि एटम जो है अपने आउटर मोस्ट ऑर्बिट से इलेक्ट्रॉन को रिमूव करे. और आयोनाइजेशन एंथैल्पी की बात करें तो फर्स्ट इलेक्ट्रॉन रिमूव करने के टाइम पे जो एनर्जी होती है वो फर्स्ट आयोनाइजेशन एंथैल्पी, उससे सेकेंड आयोनाइजेशन एंथैल्पी ज़्यादा होगी. और सेकेंड से थर्ड में जाएंगे तो वो बढ़ती चली जाएगी. This is the value that is just for your knowledge. So first is boron, then thallium, then gallium, aluminium and indium. This is the actual order. In a thallium there is involvement of 4f14. That is the reason thallium will come first. In a gallium there is involvement of 3d10. Electronegativity. As you go down in a group, metallic character decreases, so electronegativity also decreases. Okay, but in aluminium there is amphoteric nature, in a gallium there is amphoteric nature. So this is the order. Boron is the most electronegative element of this group. Boron is extremely hard and a black color solid. Melting point and a boiling point of boron are very high. The order of melting point of group 3A elements is as follows. See, in a gallium there is exception. Due to a strong crystal lattice, boron has the highest melting point. Then aluminium, then thallium, indium, and at last gallium. The order of boiling point of group 3 element is given as follows. Due to large difference in temperature between melting point and a boiling point, gallium is used as a pyrometric liquid filled in a high temperature measuring liquid thermometers. Density. Density of the group 3A elements increases down the group. As atomic number increases, mass increases, so density also increases. Metallic nature, as we have discussed, students, as we go down in a group, metallic character increases. Fine. So, boron is a non-metal, aluminium is a metal, so boron is a less, gallium, indium, and gallium and indium, and then at last thallium. This is the order of electropositive character or a metallic nature. गैलियम एंड सीजियम आर द मेटल्स कि उसको हम अपने पाम में रखेंगे तो उसकी गर्मी से भी वो मेल्ट हो जाए. इलेक्ट्रोपोजिटिव कैरेक्टर बोरोन, एल्यूमिनियम, गैलियम, इंडियम एंड थैलियम. एल्यूमिनियम के आसपास आपको एरो ध्यान से देखना होगा. पायरोमेट्रिक लिक्विड के अंदर क्या यूज़ करता है? गैलियम यूज़ करते हैं हम. Okay, so in the next class we are going to discuss in detail about the chemical properties.